Event-driven architecture provides the foundation for designing the microservices interactions. In this lecture, you will learn about events, you learn about the event-driven architecture, and I will compare a piece with event-driven architecture. I will start this lesson by discussing a common online shopping scenario. Customer pays for the products in the basket. At that point, various actions are taken. An email is sent to the customer informing the confirmation of the order. The shipping department ships out the order, and at the same time, the inventory system updates the number of products available in the inventory. So, this customer checks out is of interest to multiple subsystems in the online shopping system. There's something of interest, which is the customer checks out, is referred to as an event. And all of the subsystems that are interested in getting notified about this event are referred to as the consumers. Events occur naturally in all business scenarios. Let me give you a more formal definition of events. Events are an indication of something of significance that has happened at a point in time. There are consumers who are interested in knowing about the events, so they would like to be notified. So when an event occurs, one or more consumers are notified about the event. On receiving an event, the consumer starts processing, and the processing of the event is independent of the producer of the event and other consumers of the event. Event-driven architecture is a software architecture paradigm that promotes the designing of systems as a collection of loosely coupled components that act as an event producers and event consumers. Central to the event-driven architecture is an event backbone. Now, this event's backbone is an infrastructure component. You may think of it as a mid-tier component. It's also referred with multiple names like event bus, events broker, events router, events mediator, events hub. These are some of the common terms used for this component. The name depends on the product features and functions and the vendor marketing these products. I suggest that you carry out your own research on Google. You will find tons of information. The important thing to keep in mind is that conceptually they are similar. They all provide a way for routing of the events, from producers to the consumer. Producers of the event inform the event's backbone of something of interest happening. And they do this by way of a synchronous mechanism exposed by the event's backbone, and when the event's backbone receives the event, it figures out where that event need to be routed, depending on the consumers that are interested in that event. So, for example, the eventer will be routed to the consumers who have subscribed for event. Similarly, event B will be routed to the consumers who have subscribed for event B, and same thing happens for other events. The important thing to keep in mind here, from the event consumer perspective, is that they are not polling for these events. They get notified. Let's take a look at a specific example of event-driven architecture. Let's assume that Kafka is in use for event routing. Recall the example of a bank where when the new bank account is created, there are multiple components that get notified and carry out the processing. So here in this scenario, these three components will subscribe to Kafka for the events related to the creation of new account. When a new account will be created in the account component, it will connect with Kafka and publish a message to the new account topic. Kafka at that point will notify all of these subscribers for the new account event. Now, if you're thinking that this is the same as the pub sub messaging pattern, then you are right. Pub sub messaging pattern is commonly used for the realization of event-driven architectures. Next, let's talk about the data in the event messages. The content of the message may be the state data or the metadata. In the case of the new bank account example, the state data will be all of the information related to the new account. So the consumers receiving the message representing the event will get all of the relevant state data, and they can carry out the processing using the state data that they will receive in the event message. It is also possible to design the event structure such that it contains only the metadata. In the case of the bank account example, it may just have the account number for the new account. The consumer will receive this metadata, and some of the consumers that may need detailed information about the account may have to reach out to the producer to get all of the data needed for their processing. You would use both the state data and metadata in your event messages. There is no hard and fast rule, but certain considerations. If the method size is too big, then there may be challenges related to latency. So in that scenario, you may consider to use only metadata in your messages. If the consumers are leading to a lot of chattiness in your application because they are reaching out to the producer for getting the state data, then maybe it'll be a good idea to go over the state data in the event message. Next, I'll discuss the API versus event-driven architecture. APIs are directed commands, whereas events are observables. The central theme in an architecture that depends on either is an orchestrator, and orchestrator may be thought of as a centralized component that holds the business logic and the flow decisions. When the orchestrator needs to do something, it invokes an API, waits for the response that invoke other appears to carry out the required business processing. In the case of event-driven architecture, the orchestrator is replaced with event producer and event consumers. These event consumers are the observers of the events which are produced by the event producer. One big difference between these two architectures is that the event producers and event consumers all have business logic and are responsible for achieving the desired results from the business process. The event producer does not make a direct invocation on any component. Rather, it simply triggers an event, a message that is passed on to all the consumers. Keep in mind that event producers may also be event consumers and event consumers may also be event producers. Let's talk about the differences between API and event-driven architecture. In the case of APIs, the caller has a knowledge of the API endpoint, whereas in the case of events, producer doesn't know anything about the consumers. APIs are synchronous, meaning that the caller has to wait for the response to come back. The caller is blocked, whereas in the case of events, a producer just emits an event and moves on. Now, it does not even depend on the availability of the consumers. So what that means is that it can lead to higher availability in case the consumer is not available. The producer moves on, and when the consumer comes up, it receives the event data. APIs are based on the request-response paradigm. Whereas in the case of events, the message consists of event data, which can be the state data or the metadata. In the case of APIs, even with the distributed architecture, there is a relatively high level of coupling between the API caller and the API endpoint, whereas in the case of events, the event producers and the event consumers are highly decoupled and the architecture itself is extensible. And the reason is that you may add or remove consumers without impacting the producer in any way. Typically with APIs, the business logic is centralized, whereas in the case of events, the business logic may be spread across multiple components. And each of these components, the producers and the consumers, have the autonomy to make business decisions with their peers. It is easy to understand the flow because the business logic is centralized, but event-driven architecture, it is relatively difficult to follow the business logic. The key takeaways from this lesson is that events indicate that something of significance that has happened. Event-driven architecture is a software architecture paradigm which is based on events by nature. Either uses asynchronous communication between producers and consumers. Either is highly decoupled and extensible, and the business logic and the business processes in the case of EDAs are decentralized. That means all of the components in the system have some business logic which may be managed independent of other components in the system. That's about event driven architecture. Really nice concept, easy to use and easy to get started. If you have any questions, then put them in the comments section. Don't forget to hit that like button and subscribe because I have lot of videos coming up for you. I would like to say thank you for watching and we catch you in the next video.